Single work center priority sequencing rule problems are usually pretty easy to recognize because there'll always be a list of the jobs to be done and the processing time and the due dates. If you were a little confused about how to get started on this very short problem about job Oscar and job Denver and job Lena, it might be that you just didn't recognize that exact same kind of problem, except it's being described verbally instead of in that table that we're used to looking at. Okay, now let's take a look. Consider the following three jobs. Job Oscar requires 2 weeks of work and is due in 4 weeks. That's its processing time. That's its due date. Job Lima requires 3 weeks of work and is due in 5 weeks. Processing time, due date. Job Denver requires 1 week of work and is due in 3 weeks. Processing time, due date. Now, what are the questions? If these jobs are completed in alphabetical order, that is a priority sequencing rule. It is a rule for setting the order of things. What is the tardiness associated with job Oscar? Oh, okay. So, first off, we recognize what rule are they asking for? Alphabetically. Okay, fine. Next, we should produce the sequence. They didn't ask for the sequence. I mean, how do these list in alphabetical order? But then we need to calculate the flow time in order to calculate the tardiness because they asked for average tardiness. All right, I've got a plan. First, the sequence. Well, let's see. That means that if they're in alphabetical order, job Denver would go first, right? And then job Lima would be second. And then job Oscar would be third, and there's only 3, so I'm done with the sequence. There's the schedule. I do need the flow time. Okay, the flow time for the job called Denver. If we do it first, job Denver requires 1 week of work. That means it will be done in 1 week. Lima has to wait for Denver to finish. So Lima waits 1 week, plus job Lima requires 3 weeks of work. Got it. That means that the flow time for job Lima is 4 weeks. It'll be finished 4 weeks from now. Let's see, I used that one as well. Oh, Oscar waits for 4 weeks. Plus Oscar is what? 2 weeks worth of work. That means Oscar will be finished up in 6 weeks. Okay, now I have the flow time of this sequence, and quick check on my math. The flow time of the last job in the sequence, what is it? It's 6 weeks. Check on my math. Go up and just add the durations together. Okay, 2 weeks, 3 weeks, 1 week. They add up to 6 weeks. In single work center priority sequencing, it doesn't matter what order you put the jobs in, the flow time of the last job should equal the sum of the duration data, because it doesn't matter what order you put these in, you should always have the same make span. It's 6 weeks worth of work, and I'm glad to see that 6, because if this number had come out to be something different, that would be a tip that I must have messed up the calculations in here, but I didn't. All right, now we know the flow time for the alphabetical sequence, but it didn't ask about flow time, it asked about tardiness. Okay, time to finish this. Tardiness. That's where I take the flow time, I needed it, and I compare it to the due dates. Now, the job called Denver will be done in 1 week. The flow time is 1 week. Denver is over here. Denver is due in 3 weeks. So Denver will be done early, basically, or the tardiness is 0. The job called Lima, flow time is 4. It will be done in 4 weeks. Look up Lima. Job Lima is due in 5 weeks. Oh, okay, so job Lima would be done early also, which means the tardiness is 0. Job Oscar will be done in 6 weeks. Look up the due date. Oscar is due in 4 weeks. Uh-oh. We have run into a little bit of trouble here. It's due in 4 weeks, so its tardiness is 6 when it will actually be finished. Minus 4 equals 2. Oh, and that actually is the question that's being asked here. Not the average tardiness, but the tardiness. Perfect, we just found it. Associated with job Oscar. Unfortunately, if you follow the alphabetical sequence, job Oscar is going to be 2 weeks late. All right, now that was that question. How about this one? If these jobs are completed in alphabetical order, ooh, that's good. because that's what we just did up here. We can use our work. What would be the make span of the schedule? Oh, I was just talking about that. That is super easy. 6 weeks. Okay, the make span of the schedule, the total amount of time it takes to do everything, Denver, Lima, and Oscar, is the flow time of the last job, but that's also the same thing as just adding up the duration data. Okay, it's 6 weeks worth of work. Will be done in 6 weeks. Okay, so that one was easy. What about the next one? If shortest processing time were used to sequence these 3 jobs, popularly abbreviated as SPT, what would be the average flow time of the sequence? Okay, so first we need to create the sequence. Shortest processing time. What we do is we look at the data for fine. Who's the shortest here? 2 weeks worth of work, 3 weeks worth of work, 1 week worth of work? Oh, Denver is. So Denver goes back to the front of the sequence. Then who is the next shortest job? 2 weeks versus 3 weeks. Oscar is the next shortest, so this isn't the exact same thing as the alphabetical. Oscar, and then Lima would be left for last place. All right, so that's the sequence. We have to calculate the flow times in order to calculate the average flow time. So, the flow time for the job called Denver, well, if we work on it right away, it's at the front of the sequence, and it's 1 week worth of work, will be done in 1 week. The flow time of the job at the beginning of a sequence is always just its processing time. In the case of Oscar, it must wait 1 week, the flow time of the job before, plus how long does it take to actually complete Oscar, 2 weeks. The flow time for the job called Oscar is 3 weeks. Lima must wait those 3 weeks, the flow time of the job before, plus Lima is 3 weeks worth of work. So the flow time for Lima is 6 weeks. Now, and I'm again, glad to see the 6. It was a different sequence, but when we got down to the last job, the flow time was 6. Okay. Now, what was the question? The question, what was the average flow time? Right, that's kind of a performance score for a sequence. And that just means you average the flow time, so you average the 1, the 3, and the 6. So 1 plus 3 plus 6 is 10, right? There's 3 jobs. The average flow time then is like 3 1/3. Average flow time for this particular sequence, this being the shortest processing time sequence.